Today we are going to talk about an open source security layer for wireless routers connected to the Internet of Things. The Internet of Things is the idea of every different device and a lot of different devices getting interconnected to a network and being connected to themselves. This is going to happen according to researchers in the future, and we are going to be expecting new non-traditional devices that have never been part of the network to actually get incorporated into it. For example, your fridge or your door. This, of course, raises a lot of security concerns and issues, as things that we didn't have to worry about network security issues before are going to become a new problem. As we can see in this graph, it shows an example of how some devices are going to become part of the Internet of Things. For example, the smart thermostat has some of the highest percentages. Now, we never had a problem with a smart thermostat having a security issue, but now, with the Internet of Things, we will have to worry about it a lot more.
So, what is the problem here? Well, growing number of devices means that they have to be connected with each other, and they have to be connected with each other via some media. And this media, right now, is routers. And from what it seems, it's going to be continued that way in the industry. And the problem here is that router security is not well standardized, and there are no software updates for routers, at least for a majority of them. And our solution to this problem is an open source security layer for the wireless routers. What would it mean is that having a security layer that is an open source, that is reviewed by the broader community, would ensure that the solution is more secure. And moreover, it means that this solution would be able to be updated when the problems are found. And potentially this solution would be applicable to all the routers from all the manufacturers because it is an open source. And I just want to give an example of how successful an open source project may be. And the great example of this is an OpenSSL, which is a library for, of course, an open source library for encrypting internet traffic. And how it works is that OpenSSL has a huge user base, and the huge user base means that security problems are quickly identified, and when they are identified, they are fixed by the community experts. They provide feedback on how to avoid these problems in the future, and this in turn increases the security level of the OpenSSL. There's also a lot of academic research going on in this area, and this is obviously more complex system, but these are the key things that influence the security and usability of OpenSSL, and it's widely adopted in the industry. And the impact of this solution would be that there would be a universal security layer for the routers that would be very easily configurable, or at least it would be designed in a way that it's easier for the end user to use than the solutions which are in use today. And the updates of the security holes would be quick, which means that if the security hole is discovered, the contributors of the library fix it, and the new updated library is pushed to the routers, and the global user base are secure.
Now, when it comes to the solution realization, in order for our solution to become alive, the first thing we will have to do is gather a team of experts and contributors that are going to be willing to produce this open source software. And the system will have to be designed with some specific goals into mind. One of them is security, another one is adaptability and scalability. And of course, having a universal router API, which is going to allow different router producers to be able to use this software with ease. Furthermore, one of the main goals would be to balance between security and ease of use, which would be quite helpful, for example, when a non-advanced user should be able to configure the router in the ways they are going to be using it and with the security parameters that they are going to be found useful. Now we did some SWOT analysis on our solution, and more specifically when it comes to the router industry and not so much the Internet of Things. So the router industry is going to benefit, and one of the strengths it's going to have is from extremely low cost of incorporating this software into the routers, because it's going to be completely free and there won't be a need for development of the specific software in order to be used with different routers. Furthermore, it's going to provide extremely fast bug and problem fixing due to the huge developer base that an open source project like that will have, as for example with OpenSSL. One of the main weaknesses is that even if the software is going to be universal, there's still going to be need to be able to be customized. So in order for hardware issues to be avoided by different manufacturers, as we've seen that sometimes is a problem. One of the biggest opportunities, of course, is that universal open source software will make the router industry, more accessible to smaller companies and promote healthy competition, as smaller companies won't have to spend huge amounts of money to produce a basic security software in order to protect the customers. And the biggest threat is, of course, that governments or corporations might be reluctant towards changing to open source software, because it might lead to segregation of the industry, which might be quite problematic in the widespread release of the open source solution.
So when it comes to scalability, we have to take into consideration the size of the Internet of Things. It's going to be an incredibly large and complex software project, and the Mythical Man Month states that when we have projects of this size, there will inherently be bugs that we don't catch upon release. So an example of this is an operating system. When that's released, bugs are discovered by the users. Bug reports then come back and the company fixes them. With this router solution, the open source solution, bugs will be discovered by the community. So hackers can exploit these bugs, and then because it's such a big community, they then fix the bugs. So a hack technically makes the solution stronger. With the marketplace, as the market grows and more manufacturers come to the market, as it scales up, as we've seen from the previous slides, we're expecting more devices to come online. Because it's an open source router solution, all these small manufacturers are invited to join. They can all get a copy of the software and they can innovate their products. So this open source solution nurtures innovation, and it's an organic growth. So as more devices come online, different types of devices come online, these routers and this open source software will be equipped to take care of that. So in a worldwide context, devices and routers will be made all over the world, in different countries, with different codes of practice, different frameworks, policies and laws which govern how those devices are created and used. But ultimately those devices are going to be used all over the world. So one way to guarantee security when implementing the routers is by use of an open source. If everybody has access to the same solution, then everyone can construct devices which ultimately work all over the world. So there are a lot of research from academic institutions, companies and governments going into this, so they are aware of the problems with routers, commercial routers that we have now, and the types of routers that we might need in the future. But ultimately we won't know the size and extent of the problem until the Internet of Things does come online. But ultimately we think that the open source solution to the router software is the best one.